curious about and trying to add radicals yesterday in our lesson 2. So in lesson 3, we're actually doing operations with radicals. So we're going to add and subtract them. And when we have radicals, which is a square root, the only time you can add them or subtract them is much like terms with variables. Okay, so just like up here in this example, if I have a 4a and a 2a, I have 4 a's and 2 a's, so I have a total of, add the 4 plus 2, 6 a's. And same thing for subtracting. If I have 9 b's and I take 2 b's away, 9 minus 2 would be 7 b's. You're going to treat a radical much like you would a variable. The only time you can add or subtract them is if they have like radicals. So take a look at this one right here. We have a 4 square root of 5 plus 2 square root of 5. So we keep the square root of 5 because if I have 4 of them and to add 2 more of them, now I have 6 of them. 6 square root of 5. And just like variables, it's okay. We can only add or subtract like variables, but we can multiply and divide them even if they're not like variables. Okay, so take a look at these first ones right here. It looks super scary, but really they're just like terms. So we have a 3 square root of 3, we have a negative square root of 3, and a plus 8 square root of 3. Remember, this negative is really like a negative 1 square root of 3. So that's negative 4 square root of 3 plus 8. So negative 3, negative 4, and negative 4 plus 8, because I'm adding my coefficients, I get 4 square root of 3. We can only add them if our radicals are the same. So take a look at the second example. In this one, we have 2 different types. We have one with an 11 as a radical, and then we have ones with 3's as our radical. So just like as if it were an x and a y, we can only put the 11's together. We can only put the 3's together. So we add the coefficients. 7 plus 6 is going to give me 13 times the square root of 11, and then negative 4 and negative 2 give me negative 6 square root of 3. All right, what about this one? Yikes. Okay, so we don't even have, or we do, we need to simplify these first. All right, in the first one, it is a square root of 1 over square root of 3, which square root of 1 is 1. But if I have the square root of 3 on the bottom, I have to rationalize that denominator. All right, which means I have to take this times the square root of 3 over the square root of 3, which gives me square root of 3 over 3. Plus, on the other side, simplifying 48. What can I take out of 48? And the answer to that question is 16. This is the square root of 16 times 3, which would be 4 square root of 3. So I'm adding them. Now, at least I have the same radical, but now look what I have. This is essentially a 1/3. So it's like 1/3 times the square root of 3 plus 4 times the square root of 3. And now whether you write, actually I shouldn't say that. You probably shouldn't write it as 4 and 1/3 times the square root of 3. You should make this improper. So this, if I'm finding a common denominator, I would have to take this times 3 over 3, which becomes, I'm running out of room, square root of 3 over 3 plus 12 square root of 3 over 3, which gives me, keep the denominator, 13 square root of 3. All right, so that one makes it significantly more complicated. All right, moving on then. Hope we don't have too many of those. Okay, so adding, subtracting if we do not have like terms. Okay, so most of the time if you're going to add or subtract without like terms, odds are something in here simplifies down to like terms. So we need to simplify them first because at this age, I can't combine any of them. All right, so 28, what perfect squares are in 28? The answer to that question, I hope you know, is 4. So if I take the square root of 4, which is 2, I have to bring that out here. And I get negative 10 square root of 7. What comes out of 63? That would be 9 and 7. Bring that out here. So plus 3 times 6 is 18 square root of 7. And guess what? Minus 11 square root of 7. And now I have 3 like terms. And I have a negative 10 and a negative 11, which is negative 21. Plus 18 will give me a negative 3 square root of 7. All right, let's try the second one. Now I have a square root of 18, a square root of 32, a square root of 72. I know that in that first one I have a 9 and a 2. I know that in that second one I have a 16 and a 2. And in this third one, I know 72, a lot of you jump right away to 9. However, there is a bigger one that goes in there. And I hope you can figure it out. It is 36 times 2. And you probably would have figured it out after you simplified and you didn't have another one that was alike. Okay, so I can take this one out, multiply it by 3. I can take this one out, multiply it by 4. I can take this one out, and I have a 6. So now I have 6 square root of 2 plus 8 square root of 2 plus 6 square root of 2. Combine like terms because they're all like radicals. So 6 plus 6 is 12, and 8 is 20 square root of 2. Not 20, sorry, 20 square root of 2. Not bad. Disregard the blob. All right, so let's move on and let's talk about what happens when we multiply. So we've already kind of been doing this. We have multiplied radicals and complex radicals. So the numbers out front, the coefficients are multiplied, and then the square roots are multiplied. Just remember, when you have a square root of a number times a square root of itself, it's going to be that number. Some of you discovered that yesterday. All right, so let's flip her over and see what we've got here. Okay, how about this one? So 4 times 6 is 24. And 10 times 5 is 50, which I can then take out 25 times 2 and make that a 5 out front. So I got 120 times the square root of 2. Now, I've showed some of you this trick, and if it doesn't make any sense to you, just disregard it. But I do want to show this, okay? I tend to, just to keep my numbers smaller and easier to deal with, I tend to go ahead and multiply 6 times 4, I get 24. But inside, instead of writing 10 times 5, I will sometimes break this 10 down because I know that's 2 times 5 times 5. Now, why do I do that? Because when I see a pair of numbers in here, I know that 5 times 5 is going to give me 25. And essentially, when I take the square root of that, I'm going to get 5 out here. So it does save me some time. But I'm really good at factoring down my numbers quickly. So it really just depends on you. This is just as easy for the most part, whatever you'd like. So 120 times the square root of 2. Going to end up the same way as long as you don't make an error. Okay? Take a look at the second example. What they're doing is actually distributing. It's a lot of notation in here. So we're distributing that one to each of our terms inside. So that first one, 5 times 3, is going to give me a coefficient of 15, and then in the square root, 2 times 3 is 6. Minus, because a positive times a negative is a negative, 5 times 2 is 10. But what's the square root of 2 times the square root of 2? 2, because it's the square root of 4. And so I get 15 times square root of 6 minus 20. So that second number just gets rid of the square root altogether. All right, let's do a few more like this. In the box, in the middle of the page, we are going to simplify this expression. So 3 times 2 is 6, square root of 12. 12 breaks down to 4 and 3. And so we're going to take this 4 out, make it a 2. So we got 12 times the square root of 3. Or however you want to see that. Okay? Distribute this. So in this first one, 3 times 2 is 6. Square root of 5 times square root of 5 is 5. 3 times 5 is 15. Square root of 15, because 5 times 3. And so I get 30 plus 15 square root of 15. And in this last one, when I square that, that means I'm taking 5 plus the square root of 3 times 5 plus the square root of 3. Now, unlike yesterday when we talked about conjugates, if I'm squaring it, my signs aren't opposite. So it's not just going to disappear. All right, so I'm going to get 5 times 5 is 25. Then I'm going to get plus 5 square root of 3 from here to here. And then another 5 square root of 3, and then the square root of 3 times the square root of 3 is going to be 3, because it's the square root of 9. The thing we do have, though, is like terms. I can put those two together, I can put these two together. So I have 10 times the square root of 3 plus 28. Or if you chose to write 28 plus 10 times the square root of 3, that would be okay as well. Okay? So be prepared to see that squaring. All right. So how do we make this tougher? Well, we start putting these expressions into word problems, okay? It says find the area of the rectangle in simplest form. So when they say in simplest form, they're not asking for a numerical answer, they're asking for an expression. How do we find the area of a rectangle? Length times width. So we are going to be taking the square root of 5 plus 4 square root of 3 times 5 square root of 2 minus the square root of 3. Take your time, be diligent here, okay? So first, it's just a 5 out front and then square root of 5 times 2, which is 10. Outer, which is minus the square root of 15. Inner, 4 times 5 is 20, square root of 6. And last, we have minus 4 times 3, because the square root of 3 times square root of 3 is going to be 3. So my final answer is not very pretty. It's 5 square root of 10 minus the square root of 15 plus 20 square root of 6 minus 12. Now, occasionally, you might come across something where we can simplify these radicals and maybe come up with some like radicals, but not in this case. Not